formulas, chemical equations, and balancing equations today. Okay, so those three things. So first off, chemical formulas. Now, I know everybody hears the word chemical formulas and they think, ooh, hard, chemicals, but really, H2O, okay? Formula for water. It's got 2 hydrogens and oxygen. CO2, formula for carbon dioxide. It's got a C and 2 O's. CO, formula for carbon monoxide, a C and an O. You know, NaCl, formula for sodium chloride, an Na and a Cl. Now, some of them can be a whole lot longer than that, but they work the same way. So here's one that's longer. So it's got a sodium, a hydrogen, a carbon, and 3 oxygens. Okay, how about, it's got 6 carbons, 12 hydrogens, and 6 oxygens. Okay, but these are all chemical formulas. They just tell you how many of each element or atom. Guys, this is the last time I'm going to ask you to stop talking. I mean it. This is, I'm serious, guys. It's going to be the first 2 people I threw out of class this year, especially because you're screwing up my video. Okay, anyway, they just tell you how many atoms are in that molecule. And there are molecules with thousands of atoms, but it works the same way. You know, C2000, H4000, whatever. You still know how many there are, right? So don't get flustered that, you know, when we say chemical formula, that it's anything hard or difficult. It's just counting. It's just counting all the atoms. Okay, and that is one of the key skills that we're going to talk about. Let's do a couple examples. Like H2O, you all know, 2 hydrogen, 1 oxygen. Right? Easy peasy. Well, let's try this one. Okay, there are iron, oxygen, and hydrogen. There is 1 iron. There are 3, right? Because this means that there are 3 of those OHs. So there are 3 oxygens, and there are 3 hydrogens. Okay, so don't make this any harder than it has to be. Let's try another one that's a little harder. So this SO4, there's 3 of them. So that's the same as okay. So we have Al, aluminum, we have sulfur, we have oxygen. There are 2 aluminums. There are, look, 3 sulfurs. There are 4, 4, and 4, 12 oxygens. Okay, because 4 times 3 is 12, but that 4 is only with the O. It is not with the S. And that is really the important thing you got to get out of that when you look at that 4 only goes with the O, but there are 3 SO4s. So 3 of the whole thing. Okay, it's just counting, multiplying small numbers, 3 times 4. Okay, this skill is just counting. But we need it for balancing equations. Okay, chemical equations, we started to talk about them before. They are a lot like recipes. If we take some nitrogen gas and we react it with some hydrogen gas, we get some ammonia gas. Interestingly enough, nitrogen and hydrogen gas are both harmless, but ammonia gas is poisonous. But they use ammonia in an awful lot of things, so definitely factories have to make ammonia. And these are a lot like recipes. But in a recipe, it tells you how much, right? How many eggs you put in, how many cups of flour. So we have to tell how much nitrogen and hydrogen go in, okay? Because it's not always, like the same amount. You can't guess. We have to know how much. So we do what's called balancing chemical equations. And you have to have the same amount of atoms on the left side of the equation before as you have after. Because when we have a chemical reaction, we are not changing the atoms. We are changing how we're rearranging them into different molecules. Okay, we cannot make atoms. So we have to have the same amount of atoms when we're done as we did to begin with. Okay, we're just going to have different molecules. We're going to start with nitrogen and hydrogen and end with ammonia. And sometimes what we end with doesn't look anything like what we start with. But anyhow, we do this by first we write down every kind of atom on each side. And of course, we have the same type of atoms on each side. Okay? Law of conservation of mass. We can't create matter, we can't create atoms. So if we start with nitrogen atoms, we have to end with nitrogen atoms. If we start with hydrogen atoms, we have to end with hydrogen atoms. Okay? We can have different molecules or compounds, but we cannot have different atoms. So, and then we count. We start with 2 nitrogens and 2 hydrogens, but over here, we have 1 nitrogen and 3 hydrogens. And by the way, these little numbers are called subscripts. Sub means, under. Okay, there are small numbers at the bottom. Sub. A sub-basement is under the basement. Okay? A substitute is not as good as the original teacher in theory. Right? It's under, like the under teacher. Trying to think, submarine, underwater, at the bottom, under something. So this subscript is like under the number. Okay, at the bottom of the number. Okay, so we have a problem here because we have, we can't start with 2 hydrogens and end with 3. We can't start with 2 nitrogens and end with 1. So we are going to fill in the big numbers in front, which we call coefficients. So, and to do that first, I'm going to start with the hydrogen. I have 3 over here and 2 there. And this is kind of a little bit like least common denominator. If you had 3 and 2, the least common denominator would be 6, right? So let's try to get 6 hydrogens. So now I have 6 hydrogens on both sides, but look, I changed the amount of nitrogens. So now I have 2 nitrogens there. Okay, but I'm lucky since I have 2 there, I now have the same amount on both sides. So it is balanced. Okay, I do not have to put anything here. If there is nothing here, it is understood it is a 1. Okay, a really common mistake my students make is putting a 0 there. Well, it isn't 0 because that would mean 0 would mean you have 0 nitrogens. That doesn't work. You need nitrogen. There's nitrogen over here. So if you leave that blank, it does not mean 0. It means 1. Okay? This is another instance when we don't have to write the 1. Gonna do a couple more examples for you. Now, KClO3, when it reacts, it actually does what we do called decomposes, which means it breaks into parts. So KClO3 breaks into KCl and oxygen. We have K, Cl, and O on this side. We have K, Cl, and O on this side. We always have the same atoms. Once again, we can't create atoms. We can't destroy atoms. We have 1 K on this side, 1 Cl on this side, and 3 oxygens. On this side, we have 2 oxygens, 1 K and 1 Cl. Well, the Ks and Cls look good, don't they? But the oxygens don't. So again, we're going to put a 2 here and a 3 there. We have 6 oxygens on each side, but now we have 2 Ks and 2 Cls. Well, our oxygens are good, but like, what's going on? We only have 1 here. So we are going to have to put a 2 in there so that we have 2 Ks and 2 Cls. Okay, one more example. And we'll write down the steps here with it. So the first step is write down the elements. And then the second step, so let's do the first one first. We have Na, we have Cl, we have F. We have Na, we have Cl, and we have F. Okay? Always have to have the same ones on both sides. Second step, the atoms. We have 1 Na, we have 1 Cl, we have 2 Fs. We have 1 Na, we have 1 F, we have 2 Cls. Well, the NAs are looking good, right? Third step. Balance one at a time using the numbers in front, the coefficients. Okay. So let's try, there's 2 Fs here. Let's make 2 Fs there. Of course, now we have 2 Fs, but that also changes the number of NAs. So now I'm going to go over here and change the number of NAs. So I have 2 NAs, but I also have 2 CLs. Luckily, I had 2 CLs over there, so I am finished. Once again, I don't put anything in front of the F or the CL, so that implies there is 1. Do not put a 0 there because that means 0. Okay, we wouldn't write it down there if there were 0 of them. We already said there's some in there. Okay, so I'm going to stop the recording, but this is the recording that I will put online. So actually, and I'm putting it online for all 3 of my classes so that you can review it